Assalamualaikum and hello everyone. My name is Siti Nurlaila Nadira binti Muhammad Pakri, ID number MEC 2540885. Today I will present my project for secure software engineering titled Hands-on Comparative Analysis of Open Source Security Testing Tools. This work is completed under the supervision of my lecturer, Dr. Muhammad Zamri Osman. This project covers three categories of security testing. First, SAST, or known as Static Application Security Testing, where I use SAMGRAB to scan the DVWA PHP source code and detect injection and cryptographic flaws. Second, DAST, or known as Dynamic Application Security Testing, where I use OSZap to scan the live DVWA container and detect misconfigurations and missing security headers. Third is SCA, or known as Software Composition Analysis, where I use OS dependency check to identify known CVEs in third-party components. All testing was carried out on DVWA running in Docker with security level set to low. For target application, I use DVWA. It is a PHP and MySQL web application built purposely with security flaws, designed for training and practice. I deployed it through Docker Desktop on localhost port 80 in an isolated environment with the security level set to low to maximize the number of vulnerabilities that could be detected. Why I use DVWA? DVWA includes vulnerabilities such as SQL injection, command injection, both reflected and stored XSS, CSRF, file inclusion, and else. For tools, I use SAMGRAB for SAST on the source code, OFZAP for DAST on the running container, and dependency check for SCA against the NVD CVE database. SamGrab scanned 232 files and applied 289 rules, producing 72 findings. Based on a manual sample review, precision was around 80%. The top finding categories were tainted exact with 70 findings under injection, tainted SQL string with 14 findings also under injection, tainted file name with 11 findings under broken access control, MD5 loose equality with 10 findings under cryptographic failures, and PHP info use and CORS misconfiguration issues with 3 findings under security misconfiguration. OFZAP sent 2,401 requests to the running DVWA container and identified 23 distinct alert types across 249 total instances. Sample precision was around 60%. By risk level, there were 0 high alerts, 8 medium, 4 low, and 4 informational. Key findings include the absence of anti-CSRF tokens across 5 pages, directory browsing enabled on the DVWA and vulnerables folders, a missing content security policy header across the site, the PHP session ID cookie missing the HTTP only flag, a missing anti-clickjacking header, and the server leaking its Apache version information. Most of these are medium risk, with cookie and version disclosure issues rated low. Dependency check scanned 9 dependencies and found 0 known vulnerabilities. The scan completed in about 5 seconds, but the NVIDIA database was only 28% downloaded because it takes a very long time and even 2 to 3 days. Roughly 100,000 of 361,000 CVA records due to API rate limiting. There are two reasons for the zero result. First, DVWA does not use Composer or any package manager, so there is no structured dependency manifest for precise CVE matching. Second, the incomplete NVD database limits detection coverage. The key insight here is that zero findings does not mean zero risk. Dependency check is the most effective on modern applications built with Composer, NPM, or Maven. In a real project using a framework like Laravel or Symfony with a rich dependency tree, this tool would likely flag CVEs with specific CVSS scores and remediation guidance. This result shows that the tool application fit matters. For comparative analysis, this table compares three tools directly. SAMGRAPH produced 72 findings with 80% sample precision, tested the source code before deployment, and required no authentication. It detected OS A03 injection issues, but only partially covered A05 misconfiguration and did not cover A06 vulnerable components or A07 authentication failures. OSZ produced 23 alert types across 249 instances with 60% sample precision, tested the live running application, and needed authentication for deep scanning. It missed A03 injection due to an authentication gap but detected A05 misconfiguration through headers and A05 and A07 authentication failures through CSRF and session issues. Dependency check found zero vulnerabilities due to the partial NVD database. Tested dependencies before deployment, needed no authentication, and its primary purpose is A06 vulnerable components, which is out of scope for the other two tools. The overall conclusion is that no single tool covers all OWASP's top 10 categories. The three tools are complementary but not interchangeable.